right, let's see how you did. Hopefully, you got a chance to take a look at this information and let's see how it goes. All right. So this is talking about allowance that we're giving, and I like to put real parts of myself into this. So we're giving our son allowance, and based on the number of chores, sometimes there's 20% of the time because the lawn may not be needed to be mowed every week or whatever. 20% chance he gets $10. About 40% of the time he has the chores that he gets $20, and 40% time he gets $40. So lots on that one. Okay, so then make a probability distribution. That would then look like this. You know then that you put it into your calculator into list 1 with list 2's frequency to compute that mean and standard deviation. Now, I didn't show the work there. I should have. Okay, so do be aware of that, like I had done on the other items. I guess that I did not write out that formula on those and should have, so make sure you include that on yours. Next, then we want to see, this is $26 is what was expected with a standard deviation of 12. So is Jackson ever going to get what was expected on average to happen? And of course, that answer is no, because the only options, remember, this is discrete. The only countable finite options, there's 3 of them, $10, $20, or $40. So it's not possible for him to get that 26. Now, on an average, over time, that could happen. All right, next, we start doing some transformations. Okay, so we're going to talk about going to his grandpa's houses some weeks and some Saturday afternoons. So let's see what happens. And the grandpas, they want to support him and maybe put money towards their college fund or whatever that is. So Papa Hart says, hey, whatever you get, come on over into here and see me, and I'm going to give you what you got. I'm going to match what you got, and I'll add $5 to it. So come on over on Saturday and let me know, and we'll add to your allowance. So the function then that Papa Hart is following is that x plus 5. So it's just got that adding 5 function. All right, so then what does that do? That would mean that what Jackson is getting from Papa Hart on average is $31. Okay, so he's going to get that to put into his college fund or whatever. So that 26 plus 5. So Papa Hart's going to give him $31 on those Saturdays. With what standard deviation? How varied is it? Same variability. Plus 5, not affecting that variability, that spread. Plus 5 shifts it up, doesn't change the spread. All right, but now Papa McClellan has a different deal. He says, "Hey Jackson, because Papa McClellan lives farther away, so he needs to entice him to come further, I guess." He says, "Hey, you come on over. I'm going to double what your parents gave you. So come on down and let's see how you did, and I'm going to double what you got. So let's see." So that function, of course, from Papa McClellan is 2 times x. Okay, so how does that affect his expected value? So on average, Jackson could expect over time, on average, holy moly, he's going to get $52 a week from Papa McClellan. With what standard deviation? How varied is it going to be? Well, that multiplying by 2 did stretch that spread. It stretched it to 24. So there is more variability in what Papa McClellan gives him over time, but it is centered around 52 instead of 31. All right. Now, sometimes sometimes we'll take him to see Papa Hart and Papa McClellan. Holy moly. Then Jackson is really banking it. He's getting our allowance and then Papa Hart, Papa McClellan. So that is a combining of the variables together. Okay. So we transformed it first. And we'll actually talk about that in the next lesson tomorrow. Transforming, you want to make sure you're transforming first and then do your combining. But anyway, so let's get combined. All right. So how do the means combine? They do what you expect them to. They add 31 plus 52. So he's going to get $83 that week to add to his college fund. But with what standard deviation? Okay. I'll tell you, it's not going to be for the 12 from Papa Hart or the 24 from Papa McClellan. It's going to be somewhere in the and it's not going to be the combined of 36. Okay, it's not quite that much variability. Remember that standard deviation? Standard deviation has special rules. You're going to do the Pythagorean theorem. So you're going to do the squaring of Papa Hart's standard deviation plus the squaring of Papa McClellan's standard deviation, and then square root that. That's 2683. See? So not quite, not adding them together, not $36. All right, let's move on. Now we've got another variable. So now I have my two variables here. I've got Ian, who gets his allowance. He's older. He has more chores. He's doing some other things. So he actually averages $30 and with a standard deviation of 14. Okay, so I think I wrote that in there. Yeah, he's averaging 30 with a standard deviation of 14. Okay, so let's see what happens. So what then would do I what do I need to budget, okay, as far as paying my children weekly on average? What do I need to plan on giving my children? So I want to combine them. So that's going to be our just adding together the 30 plus the 26. Ian's average plus Jackson's average. So on average, I need to plan on giving $56 to my kiddos for their weekly needs. And with what standard deviation? Those special rules need to combine the standard deviation squared for Jackson plus the standard deviation squared for Ian. I wrote that backwards, but anyway, it's okay, same thing. Square rooting it, 1844. So that's that variability, okay? So I'm thinking in terms of how frequently I need to plan for certain things or how varied it could be from week to week. All right, what if I want to see how much more Ian is getting than Jackson on average? So this is not a combined amount. This is seeing, okay, well, what is that difference? How much difference is there really between what they are doing for me? Is it really about $4 worth? Okay, see, on average, I can tell that the difference just subtracts like normal. But does the variability get smaller? No, it does not. Wasn't sure how much Ian made. I wasn't sure. I'm finding the difference. Not sure how much Jackson made. So the uncertainty still increased. It's that idea of the cereal box and the bowl. So it stayed the same as what was in part B, 1844. The variability, the uncertainty in how much I'm giving them is still getting bigger. All right. So let's do this now. We want to take these discrete events. Okay, remember discrete events with those three possibilities. And now let's start doing some continuous normal model math, because then that opens it wide as to the different kinds of questions that we can answer based on this probability distribution and event. Okay, so we're going to draw a normal model for the differences between their salaries, their weekly allowances, not their salaries. Okay, so let's just take a look at that. Here we go. So don't get too involved here, but here we have a normal model. Okay, so let's just start with the basics. Let's walk through this normal model. And look there, it is centered at 4. Okay, so centered at 4. I labeled it. So make sure you label. This is the difference in allowances. And I have to define, so it is known the way I'm subtracting, Ian minus Jackson. Okay. So right there in the center is 4. Now, I went ahead and I put my numbers up here. You don't have to make it completely full, but here, our standard deviation is 18.44. So you add up 18.44 each time and then subtract it down each time. So that's what's going on. Now, then what we need to know, and let's see, I guess what I asked you in part A is to do this. Draw the normal model for those differences. Locate where the allowances for a Saturday are the same. So if the allowances between the two boys is the same, then when you do one minus the other, what difference is it? It is a difference, hopefully you know, of 0. So we have to locate that where 0 is. So there it is. So draw that on there. So at this point, all you have on there is what I have written in red and then this line in blue of the location where they had the same amount. So the difference is 0. Okay. Now, in part B, I ask you to go further. Label the area where Jackson's allowance is greater than Ian's and where Ian's allowance is greater than Jackson's. Okay, so this is really important that you can think through this process. So here we go. Let's talk. All right. So if Ian minus Jackson is greater than 0, because see, here it is to the right. If this part, Ian minus Jackson, is greater than 0, then what is that telling me? How do they compare? Then that means Ian's allowance is greater than Jackson's on this right-hand side. Okay, over here on this right-hand side, Ian's allowance is greater than Jackson. Okay, the other side is the opposite. On the other side, when I take Ian's and I subtracted away Jackson's, I got a result, a difference that is below 0. It was negative. So what that must mean is that then Jackson's is greater than Ian's because Ian's is less than Jackson's. I took away more than I had to begin with. So that is important. That is super duper important that you can stop and process how you can tell who's the larger amount on which side of that 0. So if you're having trouble with that, you need to stop for just a second and kind of think through that. It's an important thing to be able to get a handle on. Because now once we do that, then we're going to be asking for questions past that. And so I think then that's where we see what proportion of weeks is Jackson's allowance larger than Ian's? So I then at that point need to decide, okay, which side of this curve is this problem wanting to know? The left or the right? Well, it said Jackson's is larger than Ian's. So that's over here on the left, the blue. So hopefully you know and remember from the yesterday's lesson, we're going to get that z-score at 0. 0 minus the mean over the standard deviation. So this 0 line is located at 0.22 standard deviations below the mean. And then I'm going to norm CDF from negative 99 up to that z-score. And then that's how I get that percent of time. So guess what? That means that's what that tells me, or what the boys are going to say, because they're in competition with each other. Okay, that Jackson is going to get more than Ian on 41% of the weeks. All right, so Jackson can gloat all he wants on those 41% of the weeks, but the rest of the time, Ian's getting more. Okay, so I think that that's all that we're doing on those. Let me just double check. Yes. And so then now you're going to do your assignment on the transforming and combining random variables. All right. Good luck to you on that.